Hi, pre-calc. Sorry to give you homework after a quiz, but I'm not that sorry. I want to talk about the unit circle a little bit more. I've mentioned that phrase a little bit. We really haven't talked about it. What does it mean? And we're going to talk about shortcuts so that when we're trying to evaluate trig functions in the future, it'll go a little bit faster. So first, if I say sine of 30, we know what to do. We can draw the angle in standard position. 30 degrees looks like this. I'll drop down. We have a reference angle of 30. And I've always had you kind of just invent your own sides. Typically, I've done the short leg as 1, double the hypotenuse to get 2, and then the short leg root 3. There's no negatives here because we're in quadrant 1. So the sine ratio we can build as 1 over 2 because it is the y value over the r value. Okay, so what I want to do is I'm going to recap these 6 functions and their ratios. Okay, so sine, cosine, tangent. Okay, just to recap, we know we have y over r, x over r, and tangent is y over x. And then let's go to the reciprocal functions. So the reciprocal of sine is cosecant, reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. And obviously, since they're reciprocal functions, we have reciprocals here. Okay, this should all be reviewed to you. Now, the unit circle basically is implying what if the r value is 1? What if we just assume that this little spinny thing that goes around and around isn't just what we want to make it, but let's just always call it 1. Now, you don't have to. I'm just saying what if we did. So if r is equal to 1, the sine ratio wouldn't be y over r. We could simplify it to y over 1 or just y. If the r value is 1, cosine would just be x. Tangent doesn't really change, but it kind of illustrates the point that the tangent of an angle is really the sine over the cosine. Okay, and that's a little identity we've never stated before. All right, this is true for any circle, not just the unit circle. And then if r equals 1, these can be simplified a little bit too. Obviously, cotangent doesn't really get affected. So some people find the unit circle a little bit easier because the ratios are a tad easier. That's, again, if we assume that the r is always equal to 1. So if I come over here and decide to just think of r is equal to 1 in a 30-degree angle, I would still cut it in half to get the short leg. I would do that times root 3 to get the long leg. And sure enough, the y value gives me the sine of 30, just like it says here. I don't have to worry about the r value. You can still create the triangles like I've taught you if you're comfortable with this. I encourage it. But if you do like this idea and you like the simpler formulas and you want to always assume that r is equal to 1, you're free to do so. What I really want to spend more time on is how we can go a little more quickly when trying to evaluate stuff like this, sine of 30, or especially when it's in radians. Okay, so what I'm going to do is I'm going to make a table, and we're going to try to fill out this table, and you can decide if you want to memorize it or not. So you've probably seen some patterns emerge anyway. So let's list the main 6 functions. Okay, I typically go in this order, and then I'm going to do their reciprocals. And let's make a little table of some of the patterns we've been seeing. All right, so first of all, the most common reference angles that we can deal with are the 30 degree, which is also a pi over 6, the 45 degree, which is a pi over 4, and a 60 degree. Okay, so this is for any angle in any quadrant that has a reference angle of these values. So if we look at a 30 degree, all right, I'm going to draw it over here. If we are in standard position, there's 4 possible angles that have a 30 degree reference angle. There's this one in quadrant 3, there's this one in quadrant 2, and this one in quadrant 4. Now you might be thinking, wait a minute, when we do 30 degrees, isn't there an extra sprout here and here? Technically there is when we're trying to figure out where we are located, but this sprout here is technically 2 pi over 6's, and that reduces to pi over 3. So that wouldn't have a reference angle of 30 or pi over 6. So let's just look at these 4 solid lines here. Okay, these all have the exact same ratio with just a different sign. The y values are the same for all of them. The r's are the same for all of them. So we know that the sine of a 30-degree angle is going to be some kind of 1/2, regardless of which quadrant we're in. So if I say the sine of 210, we know it's going to be a half. We'll have to stick a negative on because we're in quadrant 3. Now I can do this also for cosine. Well, the cosine's easy to build. Cosine is root 3 over 2. And then tangent which is the y over the, we could do that later, I don't feel like doing that right now. Now let's do the pi over 4. So anything with a 45-degree reference angle would look like this or this. And again, they have the exact same x and y values. This x and this y, this x and this y, yeah, some are negative, some are positive, they're all the same. So we have 1, 1, root 2, or we can call it 1 and then go backwards with the unit circle. But let's go back to our familiarity, 1, 1, root 2. The sine of this will be root 2 over 2. And then if I want to do a 60-degree reference angle, I have these options here. So there's a 60-degree reference angle, also here, here, and here. They have the exact same x, y, and r's. So no matter where we are located, if the reference angle is 60, we'll have the same ratio, just occasional negatives. So now with a 60-degree angle, when I calculated this, I got root 3 over 2. Now, we could fill out this entire table and have all of it memorized, or we can look for some shortcuts here. Sine and cosine are co-functions. That's why it says co. So the sine of 30 would be the same as cosine of 60. Just like the sine of 60 is the same as cosine of 30. So sine and cosine are kind of a mirror image. If you set up the table this way, we have 1, 2, 3, 3, 2, 1, they're in reverse. Now we know tangent is technically sine over cosine, so once we build these, we don't have to memorize tangent, we can derive them pretty quickly. We can do sine over cosine for 30 to get this. So 1/2 over root 3 over 2 is really 1/2 times the reciprocal, which ends up being 1 over root 3. Rationalizes to root 3 over 3. We know tangent of 45 is 1. You should have that memorized. And we can do the same thing for tangent of 60. We can do this over this, simplify it, and we get this. So we didn't have to memorize this row. We can derive it pretty quickly. Now, these are the reciprocal functions. Cosecant is the reciprocal of sine. So all we have to do is if we have the sine row memorized, we can reciprocal 1/2 to get 2. We can reciprocal root 2 over 2 and rationalize. And if we reciprocal this and rationalize, you get 2 root 3 over 3. And because cosecant and secant are co-functions, just like with sine and cosine being in reverse, these two are in reverse. So this 2 goes here. This root 2 stays put. This 2 root 3 over 3 goes here. And cotangent is co-function with tangent. Root 3 goes here, 1, and then root 3 over 3. So although this is a table with 18 entries, you don't have to memorize all 18 if you don't want to. If you just memorize sine and a little bit more of the procedure, you're in good shape. I'm not saying you have to memorize this, but it might save you a lot of time. So for example, like let's just talk about how we can use this. If I want to find the cosecant of 5 pi over 3 and I have this table memorized, or I can derive it quickly, first let's determine where 5 pi over 3 is. So I'm going to set up my over 3s. Remember with the over 3s, when we're counting, we don't use the y-axis. 0 pi over 3, 1, 2, 3, 4, 5. So I'm in quadrant 4. Cosecant is negative in quadrant 4. It's an over 3, so I'm going to go to the over 3 column. I'm going to find the cosecant. We know we're 2 root 3 over 3 of some kind. And we know it's going to be negative because we're in quadrant 4. Boom, done. I didn't have to build a triangle. I didn't have to do any rationalizing. Let's do another one. What if I want to do cotangent of 7 pi over 6? Okay, well, 7 pi over 6, let's figure out where that is. Okay, the over 6 has these kinds of sprouts. 0, 1, 2, 3, 4, 5, 6, 7. We're in quadrant 3. Cotangent is positive in quadrant 3. It's an over 6, so let me go to the over 6 column. Cotangent, we're positive root 3. Boom, done. I don't have to do anything else. And then just finally, don't forget that quadrantals still exist, and this table does not really help us. So if I say the sine of 3 pi over 2, okay, the table doesn't really help us with the over 2s, though you could certainly add that column to your table if you want. But just to remind you for quadrantals, 3 pi over 2 would be 1 pi over 2, 2 pi over 2, 3 pi over 2. We can invent a coordinate, figure out what the r is. Hey, unit circle, r is 1. And we know sine is y over r, negative 1 over 1, which is negative 1. So again, you don't have to memorize this table, but if you do want to shorten your load and make things a little quicker, it might help to kind of memorize the sine order, and then everything else can be derived. Just think of it as a 1, 2, 3, all over 2. 1, 2, 3, cosine goes in reverse, 3, 2, 1. Tangent is sine over cosine, or you can memorize those. And then cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent, reciprocal of tangent. All right, have fun.